Good morning, guys. Welcome to another episode of Xa Talk Show. Today is September 28th, Saturday, 9 o'clock a.m. in the morning, San Francisco time. And today's topic is, I don't know yet, Emac Lisp Basic. So, Richard Stallman apparently is looking for a temporary housing apartment or something. He posted this on his blog, stallman.org. So he's looking, for housing, apartment, for a place to live for 2 months to half a year. It's on his website. I know that Richard Stallman in 1980s and 1990s, he sleeps in his MIT office. He just sleep on the floor, and but I'm not sure. Perhaps he has been doing that all his life. He have possibly he have never lived on his own. He's that type of person. And also, let me this is pretty bad. He is this utopia community, the GNU Free Software Foundation leader. So he is considered by many to be the god or guru sort of people. Those kind of people, it's almost like a cult leader. And today you have lots of that in the new age community, um, such as yoga stuff, those kind of thing, kind of like a cult. So let me mention this again. I talked about this again. There is this article. Uh, Let me show it. This article, the title is Why Utopian Communities Fail. This is written in 2018 by this guy, Ewan Morrison. He traveled the world and he surveyed all the utopian communities. Basically, these are the communities just like Free Software Foundation. They practice kind of commune. It's like hippies. Utopia. You live in a community. No one has higher pay. Everyone is the same. There is no officers or commanders, no leadership, no hierarchy. uh, Communities like that. There are quite a few, throughout history, and some of them still exist. Some of them moved into a little town, and they establish communities there. So the question is, what happens in these kind of communities? What's really going on? How is the power structure? How you get things done? Who buys the food? Who pays? How does it work? So he traveled and looked around, and here is his report. Uh, you know, the report is pretty good, so I recommend you read this article. Good morning, people. So I have quite a few people. Thank you for coming by. Good morning, George. Good morning to Australia. Good morning to Justin, Canada. Good morning to Bartholomew in Germany. And okay, so George says, Xa, last time I asked what your programming language would like if you design one. Do you have time to go into it today? Yeah, we can talk about that. I don't really have much to say though, because you know uh, I have written down sketches, but let me show you. So Justin says, good morning, Justin. Bartholomew says, I waited for your schedule. Now I missed 2 minutes of your screen. Yeah, I did. I only started the schedule like 10 minutes. I forgot. Yeah, might be a glitch. George says, but the stream seems to start after he was already talking about Stallman. Oh, well, Yeah, YouTube. I don't know what's going on, but anyway, Richard Stallman is looking for housing on his blog. So good afternoon. Good afternoon. Cool for school. Where you from? Cool for school. Uh, so guys, okay, type a topic, or I'm just going to go random. I don't have a fixed topic. Oh yeah, so George asked me what's my opinion about the best language. I mean, what is my language syntax going to be like? I actually have a sketch of that because I wanted to. Let's go to my programming blog. Okay, hold on a second. Let's go to Xa Talk Show, and let's get today's magnify Xa Talk Show. Let's get today's topic notes up. So Xa new page, create a new page, make it a list, post it here, go there, open. Okay. First question is, what's your language syntax? Okay, let's try to find it. I have a note here somewhere, not Emacs. Go to my programming blog, go to the diet, list matching lines. What would I search for? LAN. Okay, I think there's too many articles. I have a article written. Oh, Xalan design. There it is, the last one. Okay, here. Okay, it's a sketch. So I wrote this in 2011. Okay, last update 2015. So well, I can tell you basically my language, the syntax I want. Okay, this will lead to several interesting topics. We can talk about that. Now, if you guys have other topics, just type it. Okay. Good morning, Eloyd Anderson. So my language design. So the syntax I probably wanted to be something like Mathematica. Now that's a topic I talked about yesterday, and there is another. Um, so go to my programming languages. You go to my website programming blog, and you go to syntax soup. No, actually you go to on Lisp. Then you will see this video. This video is 1 hour talk about Lisp syntax, symbolic expression, meta expression, Mathematica, and meaning of sugar syntax. So in this article, and also yesterday in this video, also yesterday, I talked about a syntax system used in Mathematica. So first of all, that's what I want. Yes, that's what I want. The Yes, and so first of all, it's going to be 100% regular. Then it's going to have a system. There's a transformation of syntax, so that expressions such as arithmetics can be it's easy to read and it's convenient to write. So Mathematica is systematic, and also I wanted to be as another example of regular syntax or uniform syntax is XML, but XML is very cumbersome. Okay, so that's the first thing I want to have. Then no, I don't have a forum. So go with Bartholomew. Bartholomew is creating one. Okay, I have a Reddit Xali, but I haven't been actively using it. Reddit Xali fan club. Let's see if we can find it. It's basically R Xali. Okay, so R capital XAH. Now Reddit is annoying because 2 years ago, yeah. So this is my I don't post it there often. Oh, if you wanna PayPal me, here's the email. It must be this one. Must be specific. Okay, xa at xali.org. Okay, if you want to if you want to PayPal me, that's gonna be xa@xrd.org. Must be that one. Because otherwise I won't get it. I also read that in email. Yeah, you can send it to xa@xrd.org. Is your email for people on the same? I can read a message. I despise Reddit. Okay, no, I mean the email. Okay, yeah. So my language is the language I want. For a few things about matching pairs. So a little on semantics. Okay, yeah. So basically, the syntax will be systematic syntax like Mathematica. What about the semantics? I haven't decided on semantics. One of the big question to me when if I want to design a language is the first question. I mean, beside after the syntax. Okay, for the syntax part, I pretty much have a idea what I want. In fact, I would be happy just to copy Mathematica, but they may not let people do that. They'll sue you because they have copyright. Because I remember that's what happens back in 1990s. There are people who tried to create a clone of Wolfram, Mathematica, and Wolfram is not happy. They send cease and desist letters. Cease and desist is one of the jargon in idiom in English. You have to say cease and desist. It's pretty idiotic, but it has a particular connotation to it. You have to say cease and desist. So for those of you who don't know whose English is not your first language, that is. So let me show you what that is. Okay, hold on a second. Show this in browser and go through some talk show and today. And so the word is cease and deceased. Okay, I hope I spelled that correctly. Yeah, cease and deceased. It just means the cease means stop. Okay, deceased means stop. Okay, so it means stop and stop. And let me put that here. Okay, so my language design choices. So for the syntax part, it's probably gonna be like Wolfram language, somewhat similar. At least the systematic grammar. Now the semantic part, I'm not sure yet. But one of the first question before you go any further, the first question is whether it should be a symbolic language, symbolic such as Lisp or Mathematica. Again, I talked about this topic in I think in this video I talked about, yes, Lisp syntax, symbolic expression, meta expression. So check this video out. Okay, 2019 July 19th. It's 1 hour talk on that topic, very focused. It's one of the best ones of my videos. And actually, so yesterday we also talked about that. Yeah, actually, yesterday we should. Let me put that up here. So here is yesterday. We talked also about syntax system, language syntax, ad hoc versus uniform, syntax system, and syntax algebra. So this I will now put on here. So let's do it. Let me just show you some Emacs. Okay, so I'm gonna open. So what I do is, you see in the browser, I select the URL, copy it. Now I switch to Emacs. I call a command. That's XR open file from clipboard. Okay, now that file is opened. I give it the URL. This local file URL. You see that file : / / so I can open that in Emacs, and now and now I just go to YouTube section. This section I copy it, close it, and so YouTube. So I want to add another YouTube here. So I go back to my Talk show yesterday, which is this page, and now I go to the YouTube at top, copy it, copy, switch buffer, paste it here. Now show in browser. So now on this page, you see I have two videos. Yes. So now what I want to do is just I go to eShell and call command to sync to my web server. Okay. Now close that. Now I copy the file path of this file, open a new buffer, magnify, paste it here, okay, paste it there, and make it into a link with title. So now I copy that, switch to Chrome, and I paste in a chat box. And if you guys go there, now you will see, the video I just added. So those two videos, for those of you interested in syntax, watch those two videos. So let me see. Let me check over here. So we go to my website. Let's see. So that's about syntax, okay. But what about semantics? How do you want your language to be? First, I want it to be functional, okay. It's not going to be OOP. It's possible to add OOP support. I don't know. So I haven't really done anything with it. I haven't. You have to. First of all, in order to create a language, you need to be able to write a parser and compiler. I don't really know that yet. So I haven't. But I know I want it to be functional language, possibly supporting OOP or others, but functional for sure. But the first question then is whether you want it to be symbolic. So that's what I talked about in this video, whether it should be symbolic. You see languages like Lisp and Mathematica, they are symbolic, but um, but I have always been puzzled about what is the exact utility when a language is symbolic. Now, if you ask the Stefan Wolfram, the guy who created Mathematica, he'll just say, "Oh, you need to be symbolic because, because that's the most powerful." But he's, he's always uh, he's a megalomania. He's always talking about his language, Mathematica, and but if you ask Lisp people. Now this is interesting. I actually have not seen much commentary from Lisp people about why a symbolic language is that great. Yeah, I actually in my 20 years in the Lisp community, I have not heard them talk much about that. All they talk about is Marcos, Lisp Marcos. They are idiots. Okay, the Lisp people, the common Lisp people, the generation of Lisp people since I would say 1990s or 2000s. My opinion of them, they are kind of idiots. They don't see, Lisp is great, invented by John McCarthy in 1960s. It is great. It is one of the first language that focus uh, on abstract mathematical ideas. So it came from math, basically. But not today's Lispers. The common Lispers, all the Lispers I talk to, or Emac Lisp fans, they are rather extreme idiot. They are not much different from other languages phonetics such as Perl. Back in 1990s, Perl. You have everyone is a Perl programmer. There are more than one way to do it. They cite these chants all day. Then you have Python. ComSci are us, Python people. So to me, the list people, after being in the list community for 20 years, the way I see them is that they are not much different from the phonetics of the other languages, full of idiotic thoughts that they think they insist it's the best thought of all. They kind of insist. Meanwhile, if you ask them why, they cannot come out with any substance. They cannot really explain with substance. That's what happens. And also, yeah, typically what these people are, the Perl phonetics, Python phonetics, Lisp phonetics, for example, typically what these people are, these phonetics, okay, they say, or including Haskell phonetics, typically what they are is that they are just a average programmer. Well, maybe a bit above average, okay, and many of them are students in college. They are hot shots like when I was young. Okay, they are, they read a few books. They think they are better than everyone else. They think they know everything about in the universe. Sophomorons. You call them sophomorons in college. So half of them, a lot of them, these language phonetics are college students, hotshots. They think they are a bit above average and they think they know everything. But the other half mostly are they might have 10 years programming experience or 20 years or even 30. Okay, but so what they are is like typically everyone gets old. Now you are a programmer, right? Now you are a programmer. You will get old. Now I myself have like 30 years of programming experience. Yeah, since 1991. you know you will get there too. Everyone will. So you will have billions, literally billions of people all have like, oh, I'm a programmer, I have 30 years of experience. That doesn't mean you are very good or something. But anyway, so the other half of the programming language phonetics, espousing for particular language or way, is that they are just these average programmers who have 10 years or so programming language. Like in first 5 years of your job, maybe C, then maybe Perl, then maybe you learn you do JavaScript. So a few languages, let's say five. So that's the average. That's their situation. They've been programming for a long time. They know several languages, and they have opinions. Just like everyone, they have opinions. And then they have strong opinions. But yeah. So just like if you go, you just go to the street and ask any old people. All old people have opinions, right? So anyway, that's these people. They have opinions, but so what? They don't know shit. Really, they don't know shit. That's not. This is not just flaming them or unfair criticism. This is, I think this is a valid criticism, because what I'm saying is that they have never actually studied language design. Okay, that's a thing. You see, the subject matter is about language design. When you say, oh, Python is the best language, or Perl is the best, or Lisp is the best language, that subject matter is language design. Okay, now, and that's a big topic. You can dedicate your life to it. And part of it has to do with computer science. Theoretical computer science. Part of it has to do with uh, practical, industrial programming. So their experience in industrial programming certainly count, but that's not all. That's only part of it, and part of it has to do with So what's involved in programming language design? Okay, theoretical computer science, you should know, at least know the basics. Practical computing experience, programming experience in industry, you definitely, that's a asset if you know that. Okay, you definitely need that because you can, if you, like many academics, like skim people, okay, they are academia professors. They never worked in their life, in their entire life. They never, worked in industry code, coding in the industry for 1 month. So they have no idea. It's very different in academia and in industry. In industry, almost every company you go, the code, you know, the code base is like the spaghetti code. So you do need industrial experience. Okay. So anyway, so what's the elements of what do you need to know to be able to um, what's involved to design a language? What should you know? Okay, so some basics of theoretical, okay, computer science, meaning formal languages, like that, theoretical computer science, and also compilers and parser theory. Now that's a entire branch of topics you can study for years, parsers and compilers, which they kind of belong in theoretical computer science. Well, compilers also belong in the practical. You need it. Okay, so you need to know the you need to actually know well some part of theoretical computer science, automata, and so on. The different classes of language, the language hierarchy, the context-free languages, and these are important when it comes to syntax. Okay, the other day I was going to talk about it, but I kind of botched my talk because I was not able to. I was not able to teach you compiler how compiler works well because I don't know the subject well. This is like 3 days ago, 4 days ago. I made a video on that. So anyway, so you need to know theoretical computer science. Then you need to know. Uh, am I still on? Yes. Okay. Theoretical computer science. You need to have practical programming experience. Okay. Then you need to know. Uh, you need to study the system of notation systems. Okay. Notation system. For example, the history of math notations. Okay. Okay, let's search it. I have several articles of that. Problems of traditional math notation. The concepts and confusions of prefix infix. That's my troll title. Back in this is I guess this is one of my article on the anyway. It was posted to Python back then, like 15 years ago. So problems of traditional math notation. Let's write it out. Okay, so copy that. Let's put today's talk here. Okay, close that. Today's talk. Okay, and what is this? Oh, today is September 28th. Okay, language design. Wait, where is it? Oh, I'm down there. Okay, so paste it here. So Lisp index on Lisp. Okay, math notations. Problems of traditional math notations. You need to know these. Okay, and also history of math notations. Let me talk about this. So they are actually, this is not a trivial topic, okay? Because when you talk about math notations, history of math notations, in fact, I can show you several history books. I have it here. Yeah, let me just show you because it's some talk show is fun, okay? You talk a lot about syntax. Okay, Matt says you talk a lot about syntax, but there are so many factors that makes a great language. Okay, here's the thing. I know what you're saying. You are saying you are thinking, Programming language is not just syntax. In fact, syntax is probably the least important, right? That's what you're thinking. You are thinking there are so many much more important things. That's if you are thinking in that direction, that's the wrong direction actually. There are some computer scientists I can tell you right now. For example, the scheme guy, one of the racket team member, he wrote a book. I think the language design or something. And the first chapter there's a quote. Syntax, it says something along the line of syntax is the least important. The way people they are thinking, the way most programmers and some of these computer scientists, they are chanting is that they are thinking syntax is the least important because it can be any syntax. The more important thing is the semantics. Okay, that's totally wrong. Now, in my opinion, okay, this in my opinion, that's the most idiotic thinking. The most important element of a programming language is syntax. That's the most important element of programming language, not semantics. Okay, in fact, it is the syntax that determines how good is the language. Syntax alone. Now, if you interpret what I just said in some extreme sense, then that's wrong. Okay, I mean I'm not saying semantic is not important. I mean you can push it to the extreme, so you can say Ksa says language is nothing except syntax. That's obviously not true. You need semantics. If your language, for example, functional programming versus OOP, versus speed of the language. And somewhat, if you don't like me, you could say, Ksa thinks those are not important. The only important thing is syntax. That's wrong. Okay, but what I'm saying is that I showed that. Okay, we are starting to digress into lots of things. For example, let me show you this syntax soup. Okay, wait, syntax soup. Wait, shit, where is my quote? Semantic noodle. Okay, so semantic noodle. Okay, you need to go up here. Complan Pervin. Let me read my quotes. Syntax is the most important aspect of a programming language. The quality of a programming language can be judged by how much of it can be explained by its syntax alone. Okay, this is my idea, and this idea. I mean, it's not just me saying it. Okay, you are thinking, only Ksa says that. That's not true because you don't. I mean, you guys, most people, okay, programmers, they don't know shit. They never studied things. Actually, so I digressed a lot. I want to try to keep my thoughts organized. So anyway, that's about syntax. This line of thought about how syntax is the most important element, it has to do with formal languages. Okay, formal. If you guys don't know what formal language is, formal language is the heart of theoretical computer science. Okay, most programmers don't know. Fuck the industry programmers. Every day they might say, Turing machines, Turing complete. What the idiocy! Or sometimes they say lambda calculus. But you will almost never hear them mention the word formal language. Okay, formal language is the heart. If you could say it's the heart of theoretical computer science, nothing else. Okay, so that's one way to put it. Okay, formal languages. Lambda calculus is one branch of formal language. Programming language grammar, theories of parsing. That's one branch of formal language, and formal language has to do. It has to do with the foundation of mathematics. Okay, formalism, Hilbert's formalism. I start to get my blood start to boil because when it comes to the idiots of the industry programmers, formal language. Okay, formal language, Hilbert, formalism. Okay, let me magnify. Okay, formalism. Okay, one of the foundation of math. Okay, Hilbert's formalism. Okay, you can look up Wikipedia. Okay, and I have so many articles I've read, I've written, on my website. Yeah, each time I want to mention one of my articles, I have to spend 1 minute to link it. So anyways, yeah, but yeah, actually I'm going to show them because they are related. All these are related. Okay, formalism, formal language, syntax design. That's what I'm saying. Let's back to my topic about what are the elements you need to know in order to to be well educated about how to design a programming language. Okay, so let's just summarize again. So you need to know some uh, you need to know some you need to okay, let me write it down then. What's what are the things one need to know? Okay, now writing tip, 萨例 writing tip. Instead of saying one need to know, say you. Okay, you is more direct and understandable. So what are the things you need to know uh, about designing a programming language? Okay, actually, that's not the way to say it because I'm not talking about the things you need to know, but rather I'm talking about what the things you should know if you want to consider before you design a language. If you want to consider yourself very qualified to create the best language. Okay, let me put it that way. What are the things you need to know? You should know about designing a best programming language. Okay, best in some sense, in certain sense of best. Okay, because there's no absolute definition of what is the best language. Okay, depending on what's your goal of your language, things like that. So what are the things you should know? You should know, for example, first of all, let's skip the tech, the things everyone need to know. So, for example, you need obviously you need to know how to write a parser. Obviously, you need to know how to write a compiler. But I'm not mentioning them here because that's too obvious. And obviously, you should know what a function means, right? What a variable means. So that we are skipping those. So what I'm saying here is what you should know is first of all, several, let's say, 10 years of working in the industry as a programmer. Okay, that's one thing. Then you also need to know uh, theoretical computer science. Okay, theoretical, theoretical. Did I spell it correctly? Yes, theoretical computer science. Okay, then now those two items everyone kind of already know. Let me tell you what less people know. You need to know. I was starting to talk about this subject. You need to know the history of math notations. Okay, why do you need to know the history of math notations? Because programming language is let me just write the things you need to know. Okay, writing systems of the world, history of writing systems. Okay, that like English, Latin alphabet, Chinese logographic systems, things like that. Okay, writing systems of the world. And you need to know neuroscience, some of neuroscience that helps. That is, for example, scientific study of how the brain perceive text. How the brain perceive text, communication, um, science of communication, things like that. For example, science of communication, and also things like, for example, like now and then you'll see news, websites reporting these scientific findings. For example, there are quite a few scientific. There are about two or three papers, from academia. I know that talks about that research look into when you have a variable whether camel case is better or snake case. You know, You know that, right? When you have a variable name, you have a issue of style. Should it be camel case or snake case? And programmers argue about it all day. Or which is better. But there are a few academic papers that study that. So you have that. They get 100 volunteers. Programmers, and they test. So they have one program using camel case, another program using snake case. So they divide people into two groups. One is control group or things like that, and they test how fast they can understand the program, things like that. You might have seen it. Oh, you have to go in a few minutes. Okay, so okay, so yeah, so anyway, so you camel case versus snake case. Okay, so there are several papers talking about that. They give you the result. Basically, the result is not conclusive. Okay, but why am I mentioning that? Because that is an example of communication, scientific study of basically writing systems, one aspect of writing systems. So if you are designing language, you need to know these kind of things. These kind of things are part. It's part of writing system, and writing system is part of what governs how good is your syntax, because you need to know how human read it. Okay, as far as I know, like it's almost like nobody ever this language study academia or programmers in the industry. They don't know shit. Also in academia, so why is academia haven't mentioned the things I mentioned? Because academia, they flow with fund money. Where there's money, they go that way, because they don't just study random things. They should hire me. Okay, the true spirit of academia is you hire people to study things that's interesting, not following by money. Grants. That's what today's society has become. uh, so I was talking about, so one of the elements in you should know when you think you want to design a best language. Okay, one of the element is about related to neuroscience, about human brain perceived text, about science of communication, and about, for example, the papers about camel case versus snake case. Okay, that's an example of that. Okay, so let me show you. Actually, I have a article about that. Let me show you my articles. um, I'm obsessed about these kind of things. So here is my article about camel case versus snake case. I've read everything on the web. Okay, everything, and there are a few academic publications like master's thesis or PhD thesis, things like that. And I list at the bottom somewhere here. Okay, there's a PDF. Okay, for example, this one, an eye tracking study on camel case and underscore identifier styles. 2010, by Bonita Sharif and Jonathan Maleric and stuff. Department of Computer Science, Kent State University. Okay, that's one. And here's another one. Two camel case or underscore 2009 by Dave Binkley and so on et al. Then there's another one. Okay, well that those are from academia. Then you have Guido or the big shots. They want to tell you their opinions. But anyway, that's camel case versus snake case. Okay, that's one element of uh, that's one example of a study of writing systems, one aspect of writing systems, which is more efficient, which is better. Okay, and neuroscience about perception. Okay, let me show you another thing. Another, there's a collection, yeah, of articles about that. So we were talking about. Remember, we were talking about. Where was I? Okay, so I was saying you need to know the history of math notations. Okay, let me show you articles about that. Xa Li, history of math notation. Um, I don't think I have an article on that, but yeah, let me show you these problems of math notations. So why is math notation important? Because they are all related. You see, writing systems and math notation. Now, when you study math notations, and also you study the history of math notations, you learn things. For example, you will know that you know some notation. In fact, it is often the case. I think it's very significant. I mean, it's not just it's important to such a degree that many branches or advancement of mathematics, for example, calculus, okay, matrix, linear algebra, okay, and algebra. Today we have equations. Those are modern notations. Before we have x squared equals to y, something like that. Modern equation notation. Before that, we were using descriptive, like we were using English words to describe something. So we will say, x. When you have a number, then suppose that number times itself, then that number is equals to something. You use words, very inefficient. Then you have algorithms described in words. But once the math notation, the kind of the algebraic equation begin. Okay, instead of words, you have algebraic equations. You begin to have a entire branch of computer algebra. But you start to manipulate symbols, like, okay, you add a number to both sides, you add x to both sides, so the x becomes, what comes to the right side. So you can start to isolate, the variables and things like that. You do symbolic manipulation. Then after a few years you doing that, you started to realize, a automated system to manipulate symbols, and eventually that become programming languages. Today we have computers algebra system and symbolic pattern matching. If you trace the history, it goes through that. It goes through the notation for math problems. Like, instead of description, like 2,000 years ago in Egypt, in China, you don't have, for example, let me show you. Let's say x squared plus 5 equals to 10. Okay, something simple like that. 2,000 years ago, you don't have notations like that. You say it. And usually you say it like with a story. Instead of abstractly. So you say, oh, a children who we have two brothers, and their age multiplied together plus 5 is equals to 10. So what is their age? You have to. That's how you describe a problem. Then eventually it becomes then after 1,000 years or something, we got the notation. Once you have a notation, you start to do symbolic manipulation. The concept, okay, the concept of this idea of symbolic manipulation comes up. It's a new direction. Why does it come up? It will not come up without the notation. Okay, so this is just one of the example of how notations change the entire math. It directs your direction. It tells you where to go. So once you have this, for example, how do you solve this? You minus 5 to both sides. Okay, let's do that. Let's use double equal sign. So programmers are more familiar with it. Okay, so you minus 5 to both sides. Okay, so you can do that, and then you got 10 minus 5 is 5, right? So these two cancel out. So x squared equals to 5. Then you square root to both sides. Okay. Um, yeah. Okay. So let's. Okay. Then the answer is the left side cancel out. So x equals to square root of 5, right? So that is the so you see this so you are adding something to both sides, but eventually it just becomes so it becomes manipulating of symbols. And once you do manipulating of symbols for 100 years, then a new idea comes up. People start to realize, oh, then we can just act. Can it seems so mechanical. We can just automate it. That's when you have formalism and formal languages. Okay, so after you have symbolic notation, symbolic equation to describe math, then you begin then the concept of symbolic manipulation came up. Okay, and once then after you do that for 100 years, the automated symbolic manipulation comes up. Then we have formal languages. Okay, formal languages. That's the history of lambda calculus. You trace it back. Why is lambda calculus created? Because back then it has to do with math foundation. Trying to answer questions in the foundation of math. You know, uh, solving equations, things like that. Foundation of math and logic. Okay, so then you start to have formal languages. Um, okay, so that's some of the examples. This is so that's the about explaining why. So I was saying math notation, study math notation, and history of math notation is critical if you really want to design a language that's you consider best. So you need to study the history of programming language. I mean the history of math notations. Okay, so let's make that math. Okay, so here is one example of why study of history of math notation is important, because often math notations creates a entire new branch of math or entire new thought process. Okay, this is historically true. Now I'm just giving you one of the many examples. the symbolic notation for equations. Okay, that's just one of the example. Another example, for example, the switch from Roman numerical system to the Arabic number system. Okay, so are you guys still here? Another example, the switch from Roman numerals to Arabic number system. That's another example. You guys know what's a Roman numeral, right? You can look it up. Okay, so there's something wrong here. Let me fix. Okay, I don't want that. Okay, that's good. So another example, switch from and let me give you another example. Another example is matrix notation for matrix. Another example. Okay, matrix notation. So these are some of the examples where when you have a notation it's almost like it's a game changing thing. It changes the entire thing. Now let me tell you a concrete example how this influenced the programming language design. A concrete example. Okay, for example, Lisp. In Lisp, you have nested parentheses, right? And Lisp people, they say they are singing the songs of Lisp macros all day. You'll see them. Oh, Lisp macro is the best thing. Lisp macro is the best thing in programming languages. Is the best thing since sliced bread. Okay, Lisp macros. Okay. Now let me tell you this. If Lisp programming language, if they do not have the nested parentheses, the regular nested parentheses, the Lisp macro idea will never come up. Okay. Now you understand why does the Lisp macro idea come up? Because to begin with, you need a regular nested parenthesis. Then idea comes to you. Then you start to have oh, then we can do macros. We can have transformation of the expression. Yeah. So let me say that. Let me write it down. So concrete example: if these languages do not use nested parentheses for syntax, then the Lisp macro idea will not happen. Okay, that's a concrete example how critical syntax is, in my opinion. I mean, in my kind of biased or dramatic way of saying is that syntax is the most important element of programming language. Okay, so that's another example. So let's see. Let's kind of stop for a minute and see where are we going. How long have I been talking? 1 hour. Okay, good. 6 people. Okay, not many today. Okay, so far we are talking about programming language design and what makes what should you know, or what are the elements you should know well before you can consider to design a best language, some sort of best language. So you need to know, you need to have experience as a industry programmer for 10 years. 10 years is maybe high. Let's just say 5. Okay. And you need to know theoretical computer science, such as let me say this, such as formal languages, lambda, calculus, calculus, and Y combinators. Okay, for example, and the first order logic, type theory, and well, let's just say symbolic logic. Okay, let's not limit to first order. Okay, hold on a second. Okay, so you need to know theoretical computer science such as formal languages, lambda calculus, Y combinator, symbolic logic, type theory, because when you talk about computers, theoretical computer science in the branch of formal languages, because what is formal language? Formal language is all about syntax, nothing else, just syntax. All you do is find replace, it's all just strings, syntax. That's formal language is about, and that is related to the foundation of mathematics. Okay, the almost the deepest possible science of all sciences. Like people say, oh, chemistry is just applied physics. Biology, biology, chemist. There's a joke, running joke among the scientists. Biology. Chemists will say, oh, biology is just applied chemistry. Okay, then physicists will say, oh, chemistry is not, it's not important, it's just applied physics. Okay, then mathematicians will say, oh, physics, that's nothing, that's just applied mathematics. Okay, now there's one person above mathematician. Okay, that's logician. Logician comes in, will say, oh, math, that's nothing, that's just applied logic. Okay, so we are talking about logic here. And what is logic? Today, modern logic is formal language. Okay, logic, first order logic, second order logic, higher order logic, type theory, lambda calculus, Y combinators, symbolic logic. That's all in the name of formal language. Okay, and what is that? You can read in Wikipedia. Now I gave you some kind of layman kind of explanation, unprofessional explanation. Now you go read Wikipedia, you start to understand what they are talking about. Formal language. Okay, so that's important. Like average programmers, these people talking about, oh, which is the best language, they know shit. They don't know shit. Okay, like including Lispers and Haskell people. Good morning, Justin. um, So yeah, in summary, you need to have you need to have experience in the industrial programming. Okay, I explained why about that before. You need to know formal languages. Okay, then you need to know history of math notations and history of notations in general, and in general writing systems of the world. History of writing systems. That's not critical. Okay, I mean, it's certainly related, because because math notation itself is a writing system. Then you need to know neuroscience. By the way, some of these should be grouped together. Okay, it's not separate. So anyway, so you also need to know things like the scientific study of the efficiency of writing systems. That's the way to put it. Okay, so usually they belong in neuroscience, or neuroscience is one of the one way to put it. For example, how the human brain perceives text. Sentence science of communication. For example, the paper about camel case and snake case. So that okay. So what else besides that for to you need to know for designing the best language? Um, what about semantics part? Um, I can't think of that as something I need to write it down, because first of all, obviously, when you want to create a language, you need to know what it's going to do, right? So that's not something you don't know. I mean, that's not something like you. For example, like, what do you need to know before you build a car? Of course, one of the most important things is that the car must be able, you can drive it, right? But you don't need to measure it. So in the same way, what do you need to know to be able to design a best one of the best programming language? Well, depends on what you have in mind. What do you want your language to do? You know, then you need to know that. I mean, the language needs to be able to do that. For example, let's say markup languages or descript, like HTML, Markdown, those are markup, or OGMAD, or even PostScript or Tech. The job of those languages is to render things. So of course you need to know, you need to have knowledge about how such things are used. PostScript, how are they used? What are they used for, and um, how do they actually work? Things like that, like the rendering systems. So that part I'm going to skip. So because I was thinking, so okay, but what about other elements of semantics? For example, functional programming, or OOP, or array languages, or things like that. There's many branches. Or should you have pattern matching? So those kind of things. Yeah, I guess they are important. You kind of yeah, but anyway, so the thing I mentioned here is what I focus on. Okay, I kind of, I mean, to me, to my personality, I feel these are important. I mean, of course, whether it should have list comprehension, like many features. Should it have currying, automatic currying? Should it have tail recursion? Should it have core CC? Should it have a bunch of other features? That's kind of up to you. Should it have lazy evaluation? That's kind of up to what you want to do. That, yeah, you should know those. So yeah, so how do you describe those things in one sentence? How do they um, know well the semantics and styles of languages? Something like that. Okay, uh, semantics and styles and features of language, kind of like that. And also it's good to know the history of programming languages. Okay, that's very that is actually quite important, because you study all languages in the past, then you at least have a good overview of what had happened before. You know all the different ways to do things. Okay, so that's about the elements of designing a programming language. Okay, so no questions, no comments. So Justin says it's interesting that Clojure programmers don't really encourage using macros. Yeah, yeah. In Common Lisp, it was sold as the programmable programming language, and you should go crazy with macros. Yeah, the reason, I can kind of tell you what I think. Why? I kind of know why. The reason most programming language fanatics, the reason they say certain things, not because certain things are really good or something. It's really just because it so happens that in their community, it so happens it benefit them for saying that. That's kind of my outline of my thought about why certain things, a particular phonetic of a language will mention it all the time. For example, in Lisp, it typically is Lisp macros. In Scheme, typically it's tail recursion and core CC. You will find them like mentioned out of proportions all the time. In Haskell, it's monad. Okay, in Haskell it's monad. In now, so here's the interesting thing. In Clojure is one of the considered to be a Lisp family. But however, in Clojure, they don't talk about macros. This is kind of funny. Okay, they don't talk about macros. Why? Because it just so happens it's not because macro is truly good or bad, not because monad is truly good or bad, or any of these features is truly good or bad. It's just because certain things in this community certain kind of features or words that makes them feel better or makes them look better or things like that, and other languages don't have, for example. So lispers will say, oh, Marcos, because why? Because you guys don't have Marcos, I have it, things like that. And in Emacs, for example, in Emacs, it's a scratch buffer. It's the Emacs Lisp, that tends to become the identity of the language. In Haskell, it's monad, okay? So, but in Clojure, they don't have macros because let's see how let's see, in Clojure they don't have, they don't um, can you define macros in Clojure? I forgot. Okay, I don't remember. I'm not sure you can define. I think you can, but anyway, it's not emphasized. I know one thing for sure is that the Clojure language, they do not have a real reader. Okay, in these languages, you have this thing, another like identity crisis thing, identity issue. In Lisp languages such as Common Lisp, Scheme, Mathematica, Racket, okay, New Lisp. I'm not sure about New Lisp. Anyway, and so you and Emacs Lisp, okay, you have this thing called reader. Yeah, reader. It's kind of weird and complex. And okay, so reader is kind of like a parser. It just pass Lisp syntax. So you type Lisp code. The reader, it's called reader. Okay, so reader will read it. It will turn that actually into a some kind of a internal language, internal code, not bytecode, but internal list. It basically essentially it turns it into a list, into a bunch of lists. Okay, list. Then the compiler read that. Okay, read that list, a bunch of list. Then the compiler read that and turn that into either bytecode or the machine code. Okay, so 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 two Lispers, okay, like this is very idiotic thinking of Lisp, because Lispers, they have like they have a different idea of what syntax means. I have an article about that on Lisp. Okay, so you go to on Lisp. This is another one of my thing. I argued with these idiots, fighting with them for over a decade. Uh, Here, Lisp can Lisp macro change Lisp syntax? This is related to macros. Okay, in Lisp you have the reader thing. Okay, so anyway, I have that article. I'm not sure I want to. Let's see. Let me see the comments and see where we go after. Let's see where we go next. Oops, not that. Oh, we went to Racket. So actually, I want to copy that. So anyway, so that's the. So you read this article. Anyway, let me check the comments. So Justin, oh, so Clojure has limited support of macro. Yeah, I think that's why. That's why they are not so good with macros. I know one thing for sure is that Clojure, they don't have full Lisp readers. Okay, this reader thing. So reader is kind of like a Lisp parser. It's a parser dedicated to Lisp language. Okay, every all the all the common Lisp, scheme Lisp, they all have a reader. Okay, so it's a main feature of Lisp languages. So you have the reader. What the reader do is that it just read your source code. You read your source code and you turn them into a bunch of list. So for example, let me show you this example. So in Lisp you have this, right? A B. Okay, let's say I can write that. Okay, I can write this. Okay, so I have a quote, apostrophe. I have a apostrophe, then parenthesis AB. Now this is actually um, equivalent to that. Okay, but the way they are equivalent is via the reader. Okay, so when I type this line in Lisp and I run it, so Lisp reader will begin to read my code. When it sees this, it changes it to that. Okay, that's what happens. In the same way, when in a Lisp, when you have a dot b, it will be turned into const ab. Okay, so it's a Lisp reader that's doing this, and it has quirks. Okay, when you study Lisp detail, it has lots of quirks. So um, so what I was going to say. So yeah, so you have this Lisp reader thing, which is kind of odd. Then so the reader reads your source code. It turns it into basically a bunch of list like nested parentheses. Then 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 compiler reads that. Then it turns into machine code or whatever, byte code. But okay, and Lisp readers, I know in Common Lisp, and I think it's also true in Scheme Lisp, but I don't know it so well. Okay, I don't know neither of them well. They the Lisp reader you can kind of modify, so you can actually tell the reader to read your code differently. Okay, so that's why some Lispers say that the Lisp can change syntax, but actually it cannot. Okay, that's the topic of this article. It cannot change syntax. Lisp cannot change. You are forever stuck with nested paren. You cannot do anything about it. Okay, I've argued with this with many Lispers. They don't know. Um, I argue. By the way, whenever I say, these Lispers in my mind are those Lisp phonetics. So actually, they may not be they may not be the actual average common Lisp coders. Maybe those are good, but my experience came from this handful of Lisp common Lisp phonetics, and so I've been arguing with them for over 10 years. 15 years. Essentially, you could say I spent 15 years of my life doing flame war with this Lisp phonetics and Perl and Python phonetics. That's how I wasted my life. Uh, okay, yeah, you are right. So closure, they don't actually fully. I know this for a fact. Because one of the Rich Hickey, the creator of closure, he wrote an essay. They do not fully support the Lisp reader. The full featured Lisp reader, you can modify it, but not in closure. Okay, so that's one thing. So Rich Hickey, so that is also the reason a lot common Lispers I know some common Lisp phonetics, they hate closure. They would characterize closure as it's not a Lisp. I know this guy, for example. Let me show you this guy, his blog, ASCII Life Form. Okay, he has a nickname. He's known as ASCII Life Form. Where is his? Okay, let's just search my name. He's a very old. I mean, he's an old-time common Lisper. Uh, but he has a nickname of ASCII Life Form. I don't know where is his blog. Uh, Xali ASCII Life Form. Anyway, I can find it for sure. But okay, so no more comments, guys. So Matt says, let me answer Matt's questions. I recently saw a talk where language design was a topic. I think it was about the cursive IDE. One point was that when creating a language, the tooling system around it is very important. For me, I don't really get the idea about tooling. The thing about tooling, the word, the terminology tooling, and the obsession about tooling. It came up like in the past 10 years. It wasn't there before. Like in 2000s, you almost never hear about the word tooling. There's no such thing. A programming language is just a language that you don't hear about. There's no such concept about tooling. That came up a lot. I noticed in the past, let's say 5 years. Programmers will constantly say, "Oh, tooling something," or "You need tooling." So I don't fully get what's that about. So you talk a lot about syntax. Okay, I answered that question, but I answered that. Uh, how would you rank those factors? Syntax, documentation, tooling, community. That depends on what's your goal. For example, now that really depends on what's your goal, and also it depends on your language. For example, community. I mean, community is kind of a social issue. So its community is almost separate from the language, the technicality of the language. Almost, okay. Somewhat. It also depends. So how would you rank those factors? Yeah, it really depends on the person. Like, what do you mean community? Like, okay, so for example, if I create a language and I want it to be the most popular possible, that's one of my let's say that's my number one goal. I want my language to be the most popular possible. Then, in that case, I would consider community the most important between syntax, documentation, and tooling. Community is the most important because it is the people that spread your language. Okay, so this is almost like politics. So community is really nothing to do with the design of a language. It's rather about social issues. So if you want popularity, community is the most important. You better be sure. In that case, you need to be a PR person. You need to have tact. You need to learn how to talk well. You need to study those books about psychology, about how to convince people. Persuasion, to say nice things, and don't swear. Okay, don't fuck this, fuck that. That's how you wanna go. Syntax, documentation, tooling. That's kind of less important. You can get people to do it for you. Okay, yeah, that's one of the actually that's the most important thing about making a language popular. Of course, you do have some kind of technical. Maybe you do need some technical background to start a language. Okay, but once then you focus on the community. You want it to be popular, right? If that's a goal. So you focus on the community, treat people, become a leader. You have to be a leadership type of person, okay? Like when you are unsure about something, you have to pretend, at least pretend you are sure. You say, oh, just do that and be nice, okay? So there are many techniques and styles of leadership. You could be a dictator, very for example, Richard Stallman, he got kicked out now, and you can be like Linus Torvald. He's another kind of harsh kind of leadership. Harsh in some way, but not in other ways. And then you have social justice kind of leader, or you can look at all the presidents of the USA or other countries in his history. There are quite a lot of different kind of leaderships. Depends on how you want to go, what kind of person you are. But anyway, you want to be popular of your programming language, you be a good leader, okay? Then you build a great community. Then people, basically, it is the people that is the important element, not the technology. That's how company works. Google, Facebook, that's how, CEO, how you become CEO, things like that. So it's the people. You get people to like you, to support you. They will do things for you. They will create toolings, great documentation, syntax, or improve the language. That's kind of that. Okay, so that's it for today. No comments. No comments. Okay, that's it for today then. Thank you guys for watching. uh okay, I got less and less people watching. Okay, thank you. Bye guys.